Hey, what's going on, guys? Wanted to show you a quick little Python video or quick little video for a tiny tool that I wrote here. Literally tiny, one couple lines long, but it's getting after a problem that I ran into at work that didn't realize was complicated, but not necessarily complicated. It's just the tools that come available. So just give you background, the environment that I'm in, I can't necessarily just go and download new packages to solve problems that that people had or solve problems, and I can't just download code that people use to solve their problems in the open source market. So with that being said, a lot of the tools that I write or I use for my daily task um, are standard library driven, because of the fact that I don't have the flexibility of getting those extra libraries. So what I'm going to talk about, I think is pretty much covered by a lot of external libraries, but because of my situation, I needed to write something from scratch. Um, so the thing that I'm having issues with or trying to figure out is how to test network connectivity. And incidentally, and ironically, Python doesn't have a built-in ICMP ping library, which I thought was strange. But I guess it's not really that serious. But you can write it your own. But going through all the values and all that stuff, I just didn't want to go through that hassle. So kind of my own problem, right? Anyway, um, I went through and kind of researched and saw other people who did it within their own applications, and a majority of the foundation is Socket. So, me being a network engineer, I've never actually done network programming, and that's in the sense of creating the transmission highway of a application communication, meaning source and destination, as we know it from a routing perspective, but the actual communication channel that's opened up. So usually network programmers utilize sockets in order to do that. Um, so when you're connecting SSH, when you're connecting 443, you're establishing a socket over a specific port. And a protocol that runs on top of that port is usually the network programmer's logic, if you will, coded into that communication. So you can do things like encryption. Um, I mean, they have standards. TCP is a standard, UDP is a standard, but if you really wanted to, you could write your own communication protocol and use it for your application to talk. So, with that being said, um, the reason why I'm bringing up the ICMP thing is that I needed to test for host connectivity, and I came across the socket and I realized, holy crap, I could use this to build out my to solve my problem. So let me just walk you guys through the function that I wrote here. So I call it check host status, and it's going to take two parameters, host and port. Now, the first line of the function, I'm actually creating the socket class here. Um, what I'm doing is specifying the address family here, and then the type of socket, I'm addressing the socket stream. So it's a stream, meaning that there's going to be communication that can happen. I'm going to be receiving data. I can receive or send data over this stream, this socket. So what I'm going to do is I'm going to do a try and accept block. When I originally wrote this, I didn't use a try and accept block, but what was happening is that for devices that I didn't have connectivity to, the program would cancel out because I wasn't catching that error. So I went ahead and wrapped it in a try and accept block. In the try block, what I'm going to take is that same class, the socket class that I created up there. I'm going to connect to host and port. Now, once I'm connected, I'm going to do data equals send.receive, which I'm going to actually take the data out of that socket and store it in this data variable. Then I'm going to close the socket. Just for dramatic sake, I slept the program for 1 second, just to give it that, oh, I'm thinking, because it's really fast. I'm not really doing much. So, it happens in a blink of an eye. But anyway, and then once I'm done, I'm going to return the Boolean value of true, and then I'm going to return the data that I actually received out of that connection. Um, and then if it fails, what it'll do is I'm going to catch on just the generic exception. I'm not going to catch for a specific exception here. I'm just going to catch everything. And then I'm going to return the Boolean value of false, and then the actual error message that's generated from that connection failure. Now, To test this out, what I did is I created a host constant. In Python, that's the naming convention for a constant. So I created a host constant and I put my three host in here. This is actually on my live network here. And then what I'm doing is running a for loop. I'm going to list out that I'm testing the host, and then I'm going to check the host status, and I'm going to use port 22 in this particular case. So let's go ahead and run it and see what that looks like. So I'm testing. So as you can see here, I went ahead and got these results back. Now, like I said, it's pretty straightforward. It seems like a simple thing in my opinion, but it can be pretty complicated. Sometimes you got to take a step back and think about how you're going to get after it. So with me doing this, now I have a way to actually fingerprint, which I thought was interesting. I fingerprinted the application, or the SSH application that's running. So in this device, this is actually my NAS. I'm running OpenSSH 7.3, and then on my Cisco box, I'm running SSH version, or 1.99, Cisco's version of SSH. So it's pretty interesting that I can do that, but now I have a way to test for connectivity. And so here it tells me connection refused. So if the host is actually up, I got a connection refused. Let's say, well, this is up, but I got a connection refused. Let me see what host might be alive that I can possibly try. Let me see, ping, because I want to test this out. I never tested this out with a dead host. So .8 it doesn't exist on my network. So 92.168.1.8. Let's see what happens now when I run it with the actual connection that's not there. I probably got to put in a timeout value there, I'm pretty sure, because it seems like, yeah, it looks like I got to put in a timeout value there. Yeah, it looks like I'm going to have to put a timeout. Well, I got to fix that up. Actually, let's see if I can set a timeout value. Let's see. Should be able to set a timeout. So this is the interface that I'm working with. This is the package that I'm working with, granted. And so, stream. Let's see if I can get anything. So I'm going to set the default timeout with this one here. So we'll set that up here. Set default timeout, 2 seconds. Let's see if that fixes the problem. Ooh. That's not good. Let's see, send to blocking. Oh, it's just set timeout. Duh. Okay. Let's say this one. Now let's see if that works. All right, so we set a 2-second timeout. Oh, okay, there it goes, perfect. Yeah, so that's all I needed to do was set a timeout on the function there. See, this is how I solve my problems whenever I'm coding. It's a lot of going back to the reference and then looking at what methods are there and how to get after your problem. But now I got a functioning tool that I can now do and test application connections. Earlier, I was playing with this, and I did 443. Let's see what 443 gives out now that I have timeouts there. So timed out, timed out, timed out, timed out. Not surprising at all. Huh, yeah, see? So that way, it's kind of like a mini port scanner, if you will. If you think about it, do some hosting. Oh, what is this? No route to host. Interesting. Oh, I got that error message, but anyway, Yeah, I just gotta spice it up and clean it up a little bit to make it a little bit more standardized and easier to use. But this is me making my transition over into the software development stuff for networking tools. So this is you know pretty cool. So if you guys have any questions, let me know. All right, later. Peace.